Hello and welcome to this Engerati Energy Talk, which was titled Grid Scale Dynamic Demand. And Ossi, who you will hear from later, kind of pointed out and said, what is this? I've never heard about it before. We kind of made it up. We made it up for a reason, because we wanted to explore why the area around dynamic demand and demand response we've talked about for so long, why we're still talking about it, and why it hasn't actually scaled all the way across the grid. But I will just do some brief introduction to that's what the theme of the talk is. But to kick us off, I'm going to go to you, Frauke. Can you just tell us a little bit about where you come from, your view of the world, and then we'll go around the panel, and then we'll have a debate. My panelists have been instructed to disagree with each other, so it should be good.
Okay. Thank you. Yes, my name is Frauke Thies. I'm coming from the Smart Energy Demand Coalition, and we are an industry association, European industry association, dedicated to making the demand side an interactive and smart part of the energy value chain. So yeah, your question is basically also the core of our business. And I think when you're asking why is it not taking off as much as it could, we need to distinguish between two sides of demand response. One being really the demand response on the balancing market, providing services to the system operator to maintain security of the system. And the other one is demand response on the wholesale market, providing flexibility on a daily basis, which increasingly will be used also to balance off, for instance, the variations of renewables coming into the system. Now, if we look at this first part, demand response for balancing and ancillary services, I think the competitiveness is clearly there. Demand response is an attractive solution, but we have very serious barriers still in the way, and that's why it's very difficult to get this going. One barrier is to have access to demand response services for the consumer in the first place. Today, in many of these markets, demand response is not even allowed to bid. You have markets like in Spain and Italy where demand response is allowed to bid on one particular product, which is the interruptible contracts, which is not very often used, and all the other products are actually closed off for demand response and only allowed for generation. That's one thing. The other thing is access for independent aggregators who would be able to offer that service alongside retailers and other players. But these independent aggregators don't often have access. They first need to negotiate with a retailer who often is also a generator to get this access. If you let two competitors negotiate and one of them has to say, I let you into my competition area or I don't, well, then you don't get a result.
Takes a while.
Basically, that's where we need a standard framework to make this possible, to get these aggregators active on the market and drive competition forward, because the reality shows that once you have independent aggregators on the market, things will start moving more across the board. Okay. So those are some things on the balancing market. Another thing is the definition of products that are traded on the balancing market. Typically, the system needs services between something like half an hour and 2 hours. Today, often they are defined as 12 to 16 hours blocks, which is not really what the system needs. It's when you have a system that basically consists of coal plants. It doesn't really matter, because once you have your coal plant up and running, it doesn't make a difference whether you run it for 2 hours, 12 or 16. For demand response, it makes a big difference. And where there's no technical reason to have these long durations, why not shorten them to enable more competition, more products to go in, including demand response, and thereby reduce costs significantly. That's one example. There are many, many more about the not only the duration of products, but about the minimum size of these products, about some bits having to be synchronous, giving upward and downward reserve. All these things need to be looked at to see what does the system really need and what can we do to increase the diversity of parties bidding into this market. And then there are other points, such as the measuring of what demand response delivers and reliably measuring that, and then also remunerating it. Because we believe that demand response that delivers the same service as generation should also be remunerated equivalently. So these are all things that today are everything but clear and practiced today. So these are big things to work on to just create an equal footing, a level playing field for demand response to work alongside generation. So that's for the balancing markets. For the wholesale, I will be a bit shorter, but I think there are today many barriers, not only on the access, but in particular also on the signals. Today, the value of flexibility is often not really reflected in the prices, and that's not only a question of overcapacity and regulated prices in some areas, but it is in particular a question of the flexibility partially being taken out of the market and being dealt with by the TSO and spread across customers instead of really reflecting that value in the price. So what we need is scarcity pricing where it really makes sense to act in these markets and offer flexibility. And we need consumers also to be able to see what's happening with these prices in order to be able to react. And that doesn't mean that every consumer needs to shift their consumption at every single hour if they don't wish to do so. Some will want it. Some will say, I will make a contract with my supplier, my aggregator, whoever, who will do it for me within a certain bandwidth that I define. And others will say, I want 100% certainty, I'll pay for it, and I'll let my supplier make sure that things happen and things are balanced out. So again, I think on the wholesale market, it's the prices that are one of the main drivers. There are others.
So, thank you. That was a great overview of what we're dealing with. We may have bitten off more than we can chew in this panel. But Ossi, can I come to you and just tell us about how you act already in this market and a little bit of your background and how you play here.
Yes, thanks. My name is Ossi Porri, working for Helen, which is a kind of a startup. No, we were just privatized by a fully city-owned utility from Helsingin. Over 100 years old, some 400,000 customers, production, district heating, district cooling, electricity, distribution, the whole package. And sorry to say bluntly, but I fully disagree with you about these restrictions because we are up and running. We provide flexibility services for our bigger business clients, but also for residential clients. And I don't see any obstacles there. In that sense that we have several layers of demand response. We have intraday against the spot. We have a home automation service which optimizes the customer heating consumption based on the spot prices. That's something which you can buy to your home. And for the industrial users, we can aggregate the loads, and we are aggregating the loads towards the primary and secondary reserves. So the reaction times, 5 seconds, 30 seconds, how we support the grid to survive failures. So, from the regulatory point of view, sorry to say, but we earn money at the moment. Our customers earn money, real money.
Yeah.
And is that, I'm going to come back to it because I wonder whether that is a local case and maybe we can learn from it. But Sandford, can I bring you in? Can you just give your overview of and your take on what we're doing here?
My name is Sandford Bessler. I'm a key researcher at the Telekommunikation Research Center here in Vienna. We work, of course, first looking at the telecommunication infrastructure and what ICT needs also for these scenarios, like in mobility and other scenarios, electrical vehicle, remote charging and so on. So I think looking at you, I think it's a special case, maybe the Scandinavia wonder, because here we are in the middle of introducing smart meters in this country. Yeah? We're discussing about very, I would say, primitive one-directional communication, where a smart meter only sends information to your utility and the most smart meters are only allowed to be switched off, yeah? to switch off the assets and not even to switch on because it's dangerous. So we are in the middle age in this direction. What we need is bidirectional protocols like the Open ADR for demand management, demand control. And of course, the reality is like this, but since we're doing research, we have the whole internet to research and to see what can be done. And okay, what can be done is a direct load control, for example, to avoid overloads. I'm talking more about the low voltage grid because there we did a lot of research and development together with Danish colleagues and University of Aalborg in an EU project, and we developed also controllers that can use the flexibility in the house, the flexibility in the modern house that includes also electric heating, 5 kilowatt, for example, photovoltaic generation, and the electric car. So you have these flexible loads that can electrically or thermally regulate the house without that the user misses some comfort. Yeah, that's important. So you don't switching off. And having this, and by communicating this flexibility to some aggregator, the aggregator is able to schedule between these houses, which are consume much more nominally than the houses 20, 30 years ago. And even if the grid is not so powerful, by scheduling between the houses when to heat and when to charge, we are able to support higher loads. And we demonstrated this also here on this exhibition, the operation. Maybe we'll talk about later on about prices or demand response based on economic incentives.
Well, it's got to be economic, hasn't it? I mean, it's got to be driven by something. And François, let me bring you in. And can you give us a bit of a view about where you're at? And I feel a debate brewing. So, and then we'll get stuck into things.
Okay. Yeah. Thank you, Adam. So my name is François Borghèse. I belong to Schneider Electric, a large company all of you knows. Yeah. And I am working on the demand side part of the smart grid. So yesterday we get an award in the European Utility Week for our product, which manage the flexibility at the demand side level. So why do we believe in this possibility? So inside Schneider Electric, for years we have addressed the demand response in the large electro-intensive sites, and we have made the proof that it's interesting business, profitable business, either for the grid balancing operator and for the end user. This is now a real business, which in France weighs around there is a potential of 3 gigawatts of flexibility. Now, as we have not saturated, but maybe soon it will be saturated, we have to find other way of the flexibility potential. And what is just accessible is a large commercial and small industry, which in France is roughly 8 gigawatts of flexibility potential. Mm. But this drives us to other issues. So we are not managing flexibility for a flat process, but for variable processes. So it's much more difficult to predict what can be the potential of flexibility to feed the demand response, either the grid balancing or the wholesale market. So no matter, the end user don't want to know, it just provides flexibility and in return he wants to get some benefits for that. And he don't care if it's 1 second, a day ahead, or any type of mechanism. So, and we believe that this is a really future-proof solution, but which needs to solve some issues. First of all, is to put meters and control means on site, which is not obvious. And the second issue is to verify what has been curtailed. I think it has been said earlier on. It's very easy when you have a flat curve to know what you are curtailing. When you have a fuzzy load curve, it's much more difficult, and you need some advanced analytics to do that. So we believe in this market there are remaining problems to solve, but this is really promising market.
So if we take it step by step, so there seems to be a few things that are coming through. You pointed out that actually for all of this to work, we need an underlying infrastructure that enables it around comms and communications. You gave a great overview, but Ossi, you kind of came in and said, you almost said, what's the problem, we're doing it, you know, but is that because in Finland it is different, and all of those issues that you've heard articulated here, you've dealt with it already, or have you done something completely differently?
I mean, situation, for example, if I get back to these building automation systems, and I think Schneider is doing a good job. And as mentioned, that of course we have started these apples which are the lowest, the easiest ones, like backup power, residential heat loads. But when we go to the, for example, commercial sites like stores or something, and actually we had a discussion with the Schneider already and discussed about how we could predict the loads for the next day, next moments, in such way that we could aggregate those and offer for the marketplace. And it's a hard one. I mean, even though they have a very high-end building automation systems, it's still hard to make the forecast for the next day. So I wouldn't say it's a barrier, but I would say that of course if you think about the investment needed to build up the control and have the forecast against the benefits what you get from the marketplace, you have to balance these two. And what I see is that we have a long way, as we discussed, that there is a lot of potential in the market. That what I see that these are other things where we start. I mean, from the greenhouses or from the industrial plants, manufacturing facilities, and so on. And then we get near to these commercial. I mean, if you are selling clothes, if there's no lights on, I mean, there's no business.
It doesn't work for you, right? Or if you have a small shop and the fridge suddenly knocks out, exactly. It's not going to do you any favors.
Exactly.
So when you hear all of this, I mean, if we put it into context, because you know when you went through everything that you said, I mean, we could be here for hours and still talk about it. But you know, if you pulled out like one or two things which, you know, you say, okay, well, this can be done now, and we can push the agenda forward. You know, what would they be?
Okay, I think when we look again at the distinction between balancing market and wholesale market, on the balancing market, I agree with Ossi that Finland is one of those examples where things have moved quite significantly, and demand response has access to those markets. France is another example. Also in the UK and Belgium, we've seen very good progress. So on that, I think the message would be remove the existing barriers, put demand response on an equal footing with generation on the balancing markets so that it can work. And here I think we have limited infrastructural barriers, at least when it comes to industrial loads participating. Also commercial are starting more and more. And we do have members who are already very engaged in the commercial side, offering system services.
Is there any play on a European level here as well?
Yes, absolutely.
Because
absolutely.
I mean, the last time I checked, we're still inside Europe, so I can say that. But surely, you know, we've got all these great examples. I mean, and at the end of the day, if something works, why can't you just copy it?
Yeah. And there is a big process on the European level at the moment in the definition of grid codes that are being defined between ENSUI, the transmission system operator, ACER, the regulators, and the European Commission, and then have to be approved by member states. And this is something that is currently underway. The SEDC has also been very engaged in the process of defining these codes. And I think for the codes that are already quite far advanced, we've made good progress so far. Some of them are still in draft form, but we've moved forward quite a bit also on the European level. We're not there yet entirely. A lot can still happen, but the process is happening, and is happening also from the European level.
And Sandford, just to bring you in a little bit, and this may be a curveball question, so if you want to throw it to someone else, feel free. But it seems to me, do we not also need to do a better job of educating the consumer and the end customer about what can be done here? Because unless you're in this industry, if I randomly said to my friend and I said, "Do you know about demand response?" He'd go, "What are you talking about?" But certainly in commercial.
I'm not in the market or in the business. I'm in the research, but I can tell you that if you don't have even flexible tariffs, if the regulation is not so far that you can earn money with this, and you can if there is no business model and incentives for being controlled by a controller remotely, why should I do that? Normally you should have from the flexibility, you should have some remuneration, some money. But we are here in Austria far from that. I mean, we do not have.
So what do you have in Austria? You have a single tariff and that's it, or
I think we have much less than Italy. In Italy, you have weekend tariff, evening tariff. I don't know.
You guys are keeping it really simple, right?
You have night tariff and day tariff, and so nobody's using that. But this is one thing that. Because you said educating the customer does not know, And the second thing, talking technologically, I think having these systems, which are quite complex, the need have local control, have remote, so centralized control. You need the telecommunication. And once you have the telecommunication, you introduce the problem of resilience. What happens if it's plain internet and it fails? Then you need to account. You cannot leave households which are not controlled at all, because then you have a chaotic situation. So you need to, and that's what we have done. We looked at possibilities to improve the resilience of the network.
And François, from your experience in dealing with commercial customers and so on, is there a huge appetite for what these sort of services can offer, and and how variable is that?
As usual, there is an appetite for earning money. So, I think education is important. Not in details, but showing that the end user can bring something to the community, to the planet. It's an important matter. Of course, at the end, the decision will be taken if he gets money or if he finds a real benefit for participating to demand response. That's the first point. And the second point is that those, even if they are educated, they are not experts, especially in commercial building. So they need something which makes the job for them. They need to have the final decision, but they need something which makes their life easier. Take all the decision, arbitrage decision, calculate the flexibility potential. It's an upper layer to the BMS, what you call, which makes the calculation, know what flexibility potential is available for the next hours. And that's done. The end user has nothing to do with that, and he can only say, okay, during 2 and 3, there is a CEO visiting my office, I don't want any modification in the HVAC, in the climate, in the heating or in the cooling. So that's the only decision he has to take. All the rest has to be made by an automatic system which helps the end user as soon as he's convinced that it brings benefits for everybody.
So, I mean, what we're talking about, it seems to me that with there are these two sides to the coin, and is the grid balancing one just actually a structural one, a market structure? You get market structure, that market will take off, and you'll do that. Is that almost the simpler one than the one where we are involving customers and end users and heaven forbid people like me in our homes? That's a very micro level. Yeah, is that harder?
I think involving the end user and expecting every single homeowner or every single person really
synchronize the light
to synchronize. I think this is not realistic, and it's not wanted, it's not needed either. And I think this is exactly what François just described. You will probably have some customers who enjoy adjusting things on their phone and seeing what they do, but this will be a certain part of the population. That's not going to be everyone. And in the end of the day, it's about automation. It's about saying, here is my margin within which I want, for instance, I want my temperature to be between 18.5 and 21 degrees, and within that, my system can do whatever my system wants to do, reacting to the market. And I think this is more the reality that we're moving towards, that there is going to be a lot more automation. But this automation needs to be driven by something.
I mean, it seems to me that if you do something like this, and I think you were making the point off air as well, and you suddenly add a whole lot of different dynamic within the grid that was ever there before. Suddenly everything's suddenly moving, and is there a potential to create sort of fake peaks and fake loads or artificial loads that wouldn't have been there before?
Yeah, that's the case. So we observed that if we compare now and try to do demand management without using day ahead prices, just having one single price, then you have a distribution. However, as soon as you use prices, then you have the optimization creates load in the valleys where you have a small price, and then you use the flexibility and you have suddenly a peak there that you didn't have before. So and then you need some other mechanisms to bound this peak, so to pressure this peak again, and then when you do this, then you don't have the savings. We measure savings of 11% in a normal case. If you have overload, the savings go down to 2.5%, so they are negligible. And so this is the compromise you have to do. But I mean, of course, a demand response based on prices is popular. It is done, maybe not on the residential level. We know of an example from our colleagues in Denmark. They are looking at the big refrigerators in supermarkets. Yeah? So there you have a lot of kilowatt hours that you can, by more cooling or less cooling, depending on the price or the load, you can have much larger advantages. The same is if we don't have, unfortunately yet, public charging stations for many cars. So it's amazing how much power they need. So if we can do here some optimization and use flexibility to level the load, to shed the load, that is a very interesting case.
And also, one of the other things that it seems to me is that actually the industrial sector is probably the best target. I mean, I was talking to someone from IKEA not that long ago, and they have got a whole mission to, because they've realized that if they take control of their own energy destiny and properly manage it, they can affect the bottom line margin significantly in in that business. Now, it seems a little bit like, why isn't every large, and you guys will tell me it is, but why isn't every large commercial company thinking like that? Because that will drive this as well, more than anything. I mean, do you have an experience of that in Finland? You've got to tell me they are, aren't you?
Yes, of course, as we discussed about educating the customer, and also it should be easy. But usually when I go to the customer and say that for example, customer who has like 1 megawatt backup power plant, and I say to this guy that okay, if we put this machine to the market, it would be 70,000 euro for the last 6 months. Would you feel that it would be nice money? So, as we heard that it's very easy to get the things ongoing when you have. But if you are going to say that okay, I would like to discuss about with you about some demand response. I mean. Exactly.
Yeah.
So I think it's. I mean, we as professionals, I think we can blame ourselves in that sense that if we are not doing this user-centric, if we don't have such an easy way to do the demand response, if we have to explain about something demand response and primary, secondary. Frequency regulated normal market thing, then we have lost the case already.
Yeah.
As I see that it should be a kind of basic feature of our offering. In that sense that the customer don't have to understand, they don't see any discomfort or problem, even if the CEO is visiting.
Yeah.
But it's something which is a kind of background optimization for the benefit of the customer, so that they are not giving anything for the comfort or some other. But I think it's packaging, so that we together with Schneider should put up something for the IKEA that they can do it.
Absolutely, and as we're coming up to the end of our time, I'm going to give the three of you a final word as well. I mean, what would you say? Let's localize it for you here in Austria.
Yeah.
I mean, you guys must surely be thinking about this. They must surely be thinking about how we can put that into the Austrian market, or is that not the case?
Well, I'm not sure how our utilities are dealing with that. So we shouldn't forget that Austria has very strong grid, and have a lot of reserve. At the moment, there is not such a problem. The problem will come when we have whole streets, full penetration of photovoltaic, and then you will have excessive generation. Then they, instead of doing dynamically the management, they say 3 guys can put their PV panel, the 4th is not allowed on that street. So I think we can do better by having this dynamic demand management, which of course costs money because you need metering, you need telecom infrastructure, and you need analytics, you need some prediction systems. The same is with electric car charging. We know that here you have, you can have 2 cars maybe for one house. In US you have much smaller transformers and the situation is much more dramatic. once you put electric car then for 2 houses it's too much, yeah.
Well, I read
so we have
somewhere
much more reserves.
That's probably will happen in the UK as well. You know, it's
Yeah,
like,
I don't know. Here
3
we have
electric
larger
cars on the street.
transformer, a lot of reserve,
Yeah.
and the situation is not as bad yet. But if this electromobility will come, like in Norway or in Holland or maybe in Finland also, then we will have other big challenges, yeah, and then we can use the system that we are developing now.
Okay, François, a final word from you.
A final word, I think we have identified 2 end users which can provide flexibility for demand response. There is not the ideal case. Inside industry, there is a flat curve, but the process are all different. So IKEA decided to manage its flexibility, to win money, to optimize their bottom line, okay, but others doesn't. So that's their choice because they have to manage the consequence of the demand response. And on the other side, we have the commercial building, which have a fuzzy curve, but for which we address almost the same application, which is HVAC, which is almost the same everywhere. We manage the temperature, and we know how to switch on or switch off the heat pump. That's quite easy and replicable. So all have advantage or drawbacks, but all is needed sometimes for balancing the grid for both.
Well, the other interesting thing that will happen is when we start decarbonizing the heating network. You know, can you imagine all those boilers being run on electric? You know, that'll be interesting.
Huge amount of
Yeah.
potential.
Frauke, can you give us your final thoughts on this, and then we'll wrap it up for today?
Okay, well, I think we've seen that on the industrial side and especially when it comes to system services, we're already very, very far. And it's about removing the last barriers to really exploit the potential. And then we've also heard that it's much, much harder when it comes to daily adaptations on the wholesale markets and engaging smaller scale customers. So I think here our big challenge is to get the signals right, to make the experience clearer for the customer. For commercial, it's probably purely financial. For the residential, it's even more than that. So we have a lot of work there to make the value seen to the customer, both from the markets and from everything else that's combined with it. And I think that's the main homework we have to do.
Yeah. And should we stop using words like demand response, which just actually don't say what it is, and use words like energy management or here you go, you can save £70,000. You know, that keep it simple, right? So, okay, on that note, we will leave it. Thank you very much for watching. My thanks to my panel here as well. We're at the end of European Utility Week. It's been great for us, very selfishly for Engerati. We've captured all these experts for you. So I hope you enjoyed watching this. Thanks again.